Hello, everyone. Thanks for taking the time to on this webinar. And so what we've just published, or what I've just worked on, is the Global Lubricant Additives Market Analysis and Opportunities Report. Um, basically the lubricant additives market is estimated to be at over $13 billion, and that's in 2020 on a down year, and accounts for over 4 million tons of additives. Basically, the in-depth study covers lubricant additive demand by application, function, chemical class. What we try to cover is like the impact of new specifications and regulations, how that shifts, the additives, the formulations, the consumption. As part of that, we also build in like a forecast. We have a 5-year forecast, so up to 2025. The base year for the study is 2020. We also look at, because of the strange, year we've all had with COVID-19. So we looked at both the short term, and we also tried to look for, what are the longer term impacts of COVID-19? Obviously, the short terms, a lot of reduced demand in many categories, but longer term, how is that affecting us? So we looked into that in this study. We do profiles of all the leading additive package suppliers. We also look at like the opportunities and the market for each different segment, such as PCMO and hydraulic. We also look at it by chemical class, such as dispersants and detergents. So basically, that's what we kind of try to dive into in this study. So the study is pretty darn big. It's almost 700 slides. But yeah, we dive into that. We also provide a lot of the basic understanding for people new to the industry. So it's also good like that, where we'll explain, what the different additives do in different products. So for instance, the additives in a hydraulic fluid, what they're there for, what types of additives are typically in it. We put a typical formulation that would, imply it. So it's both good for people very knowledgeable on the subject. They'll skip the basic parts and then they'll jump to, what's going on in the market. But for new people to the industry, it's also good to kind of catch them up and get them up to speed. Now, let's kind of jump into some of the slides. So for the global lubricant global lubricant additives market, as I said, it's over 4,000 kilotons, or 4 million tons, right? However, it's down more than 10% in 2020 due to the COVID-19 pandemic. I mean, we all know how that's affected us. We've had global shutdowns. People have been essentially quarantined to their homes in many areas. A lot of non-essential businesses were all shut down. So this was a huge impact on additives. Now, the one slightly different aspect as far as lubricant additives goes, we had a bit of a lag in the kind of demand decline. So where finished lubricants saw the demand decline more immediately, because obviously consumers weren't driving, and everything was kind of happening at once. What happened was the lubricant marketers, or the blenders of the finished fluids, they continued to store their tanks and basically stock up. So they continued to blend their products and try to follow their forecasts as long as they could, essentially to ensure like they were covered in case they got shut down. Because the good thing is, as far as lubricants were concerned, they were for the most part still considered essential, so they were allowed to operate for a while. But it was more on the fear that they would be at some point deemed non-essential or required to shut down, that all of these guys basically, blended and packaged all the product that they could to make sure they had inventory for the customers. In hindsight, that was a pretty wise decision. Now, the biggest categories you see for lubricant additive consumption is automotive. Now, automotive covers engine oils, gear oils, ATFs, among others, and it spans across both the consumer and commercial lubricant additives. Now, consumer, as I alluded to earlier, was particularly hard hit. I mean, it declined almost 17% as far as PCMO demand is concerned. And it's because, obviously consumers, people were basically quarantined at home. A lot of offices were shut down. a lot of non-essential work sites, manufacturing plants, et cetera. They were all shut down. So essentially people no longer had the work commute. They weren't going into their office, into their plant, into, wherever they were working. And so you had a drastic decline in vehicle traffic for daily commutes. On top of that, people were limiting their, shopping excursions. So typically where maybe you might go to the grocery store once or twice a week, they maybe limited it to once a month or twice a month. And so people were just generally going out much less leisure travel as well. People were doing staycations and basically just hanging out at home with a lot of streaming movies and things. And so what you ended up having was, as I said, the consumer automotive segment really took a hard hit in 2020. The only saving grace was because these consumers were home, they were essentially shopping online. And so everybody was shopping online, and, like mega corporations like Amazon were reaping the windfalls from this. So the commercial segment, which obviously handles delivery and logistics, was able to pick up some of the slack from the loss in commuter. But overall, the category still managed to decline around 13%. Just due to COVID. Now, let's see. The second leading category is metalworking fluids. Like I said, in the study, we basically dive into every single type of fluid. So in metalworking fluids, we'll cover things like protecting fluid and forming fluids, each category, what's going on and affecting each category. But we saw that protecting and treating fluids really led the decline in that segment. Now, they aren't the major consumers of additives, but their decline was double digits compared to the other fluids. The only good thing is, obviously we expect automotive to recover quickly. They're both expected to have a fair or respectable CAGR out to 2025. So that's a good thing. And we're seeing it in our everyday life as you see a lot more vehicular traffic out on the roads. Now, if we look at it by chemical class, and as I said, we do it both by segment to see what affects each segment, but we also look at it specifically by chemical class in the study. Viscosity index improvers and dispersants are basically your leading demand chemical classes, and they account for nearly half of the overall additive demand. Now, the main segments that consume those are engine oils, but things like VI are actually finding greater use in even things like general industrial oil, which have tended to be a little more additive light in that sense. Things like hydraulic fluids and other fluids, gear oils. And the main reason is kind of this push towards a greener, lower CO2 future. So we're looking at energy efficient green fluids. And a lot of times this can be achieved through a high viscosity index fluid. Now you get that by obviously adding a lot more VI or viscosity index improver to usually a synthetic high VI base oil to start with. So you start with a 120 plus VI fluid, and then you add in VI, and sometimes you can end up on the order of like a 200 plus viscosity index. And what that essentially does is provide your equipment or your engine, whatever the application is, with a much more stable viscosity across the temperature range. And where it really helps out is the high VI fluids essentially provide a much lower pumping viscosity, a much lower energy use right in the initial phases where the equipment is cold and firing up. So for equipment that cycles on and off a lot or faces a lot more temperature fluctuations, basically high VI fluids can really help with energy savings. And there's other benefits as well, but that's one of the main drivers of like viscosity index improver. Now, in the past several editions of the study, dispersants have always led demand. They were normally number one. Lately, within the last couple editions, we've seen VI essentially creep further ahead, especially as you've seen more uptake of lower viscosity fluids in like commercial engine oils and others. So you've seen a lot more VI use. Dispersants, so basically the function of the dispersant is obviously to maintain cleanliness in the oil as well as suspend additives. They're widely used in longer life fluids As I said, they trap and dissolve any contaminants in the fluids and prevent those contaminants from agglomerating. So as I said, these dispersants, they're finding greater use in long life engine oils, as well as other long life fluids where there may not be as many contaminants, but there may be a higher additive load because it's a longer life fluid. So you might need more antioxidants, more friction modifiers, and other particular components. Well, the dispersants help ensure that the fluid is stable and that all the additives that you put in there stay in solution. Whereas if you don't have a stable formulation, especially if you let the fluid sit for a period of time, you get fallout. And some of the additive can actually crash out of the fluid. So dispersants, as I said, are finding use in new applications. In the traditional applications, as I said, engine oil uses a lot of dispersant, especially commercial engine oils or heavy duty engine oils. We're actually finding that treat rates have stabilized. They're not growing as much for each new subsequent category. Instead, what's happening is the additive companies are essentially switching to newer, more effective dispersants. So for the same physical weight or volume of dispersants, they're providing greater dispersancy. So instead of going beyond, say, like 8% per weight viscosity and dispersant content, they're just using a mix of older style dispersant as well as might be 4% of new and old, and essentially they're getting a higher dispersancy level from the fluids without actually going too much higher on the dispersant content in the finished fluids. Now, detergents are the third category. These detergents have been quite interesting in the last few years. Mainly, there's been a lot of change. Now, in the past, detergents, they've always kind of faced like an ash limit and, protection for emissions and things. So you've seen, a certain content of detergent that's been allowed into formulations. But recently with the whole low speed pre-ignition, so where you have these turbo GDI engines, if you guys aren't aware, they face an issue. Basically, in order to get the optimal fuel economy out of these engines, running at very low speeds, but under high torque load. And so you're getting this thing called low speed pre-ignition, which is kind of like a knock, but a special type where you get it only under these optimal fuel conditions. And so what happened is, the OEMs basically, and between the OEMs and the additives industry, they found that calcium detergents are a source of that knock. And with the inclusion of LSPI, that's what it's called, low speed pre-ignition, LSPI, into ILSAC GF5 Plus, and then now the current GF6, you've seen where an industry that was predominantly a calcium detergent-based industry has switched more to like a 60-40 calcium magnesium, or almost 50-50s in some cases. But you're seeing a lot more magnesium detergent use. So, I mean, this is obviously has affected the suppliers because, if you predominantly made calcium detergents, you find your customer base has shrunk. Whereas if you were a magnesium supplier, then you obviously found a greater demand for your product. On top of that, we're all aware of the IMO 2020 marine fuel. Again, everything kind of falls around emissions, but the switch to the low sulfur fuel, that's impacted the marine cylinder oil, which traditionally has been a very high TBN, basically a high base number fluid, which consumes a lot of detergent because your over-based detergents are where your TBN source comes from. And so this is that the IMO 2020 has driven a lot of decline in especially calcium-based detergents as well. So as I said, for the detergent segment, it's seen quite a bit of change in the last few years, where we've seen a lot of calcium detergent use decline, and growth in magnesium-based detergents. And this is kind of what we try to cover in the study. What people can expect, what are the specifications that might cause these shifts, and so that's kind of the fun part for me, is to dig into all these little bits. Oops, I wasn't supposed to go there. All right, let me pass it back to Robin for a quick poll question.
Yeah, thanks very much, David. Right, as David said, we have a quick poll question, and it would be really great if you could all participate. I will be launching the question now and give some time for you to answer that.
Okay, so the question is, with regards to lubricant additives, which trends are you most concerned about? Now, I'm curious, do you think it's OEM specifications and their divergence from industry specifications? Is it government regulations, be it fuel economy or, other regulations such as Europe's REACH? Is it EV fluids that you're the most concerned about, or is it green initiatives? Is COVID-19 still top of mind?
Yeah, our poll is still going, so let's wait for a few seconds. It's great to see almost 70% of our attendees have voted. So I'll be ending polling now, so David will be able to announce the answer.
Okay, cool. So looks like EV fluids and EV growth is basically the top of your concern. 53% of pollers said that, followed by carbon neutrality and like the whole green initiative at 44. The rest were all 20-ish. So cool. All right. Do I have to hit stop, or what do I have to do with the polling? Do I just hit the X, Raman?
Yeah, just carry on.
All right, sounds good. All right. All right. So, but we'll still cover some of the stuff, even though it didn't seem quite as interesting to you folks. But one of the main drivers traditionally for additive shifts and changes in demand and consumption have always been specifications and government regulations. So as far as like specifications, as I said, when you get these new specifications such as GF6 A and B, SIA 2021, API CK4, FA4, they'll drive a lot of fluid changes. As the industry goes for these upgrades, you'll see it essentially, all the major additive companies will do specification additive packages, and then these packages kind of in major markets like North America and Europe, they tend to take effect very quickly, and then they cascade out to like South America and Asia Pacific and other regions gradually as the new vehicles kind of require the newer additives. But the gist of it is, every time you have a specification upgrade, generally speaking, the additive package is upgraded as well. And obviously, they're always looking for more robust, longer life fluids. So that drives a lot of the additive changes. OEM specifications as well. Oftentimes, where industry bodies like ILSAC and API set, API SN/GF5 or something, that's sort of a baseline fluid. So you can get a fluid that meets the basic specification, but then typically OEM specifications will be on top of that. And they often have a higher level of performance required. Now, European OEMs have always been that way. You have VW, Mercedes, BMW, all of those specifications tend to require very high performance additive, basically additive setting fluid specification. So when you tend to meet those OEM specs, your additive levels are at different than you would have if you had just simply met in a SIA. Now in the US, in the past, like, probably 5+10 years ago, an ILSAC oil would have met essentially, your Chryslers, your Fords, your GMs. It would have met all these specifications. Now GM has kind of stepped out with their Dexos 1. So starting with their first generation Dexos 1, they already added, several new testing to the specifications, new requirements, to the point where the fluid that typically met at the time, like say a GF4 specification, couldn't meet a Dexos 1. So you actually had to have a slightly higher performing fluid. Now, as it's gone through the different generations, and we're seeing the release of the Gen 3 soon, the GM is really stepping out and kind of going the same way as the European OEMs, in the sense that their fluid specifications are basically deviating quite a bit from API and ILSAC. and they're really setting like the additive content, the packages for these fluids. So we're starting to see some of that. We haven't seen Ford or Chrysler invest the same as GM has into, you know, their fluid specifications. But the real interesting aspect is now there is a new, and you'll see the symbol on the top right, International Fluids Consortium. Now, what is that? That, if you don't know, is an organization that was formed in 2020. I believe Toyota may have headed that up, but I know GM helps, and Mike Kunzelman is in the organization. What that is basically it's an OEM-led fluid specification group, and so what they haven't officially committed to creating anything just yet, or they haven't announced anything just yet, as the organization was just formed. But the whole idea is they will going forward set essentially a global fluid specification, which, you know, could be beneficial to lubricant additive marketers or lubricant additive package suppliers, I should say, because instead of having, say, a European spec fluid and a North America spec fluid, you would have essentially a global spec fluid. But at the same time, the major difference for this organization and slight cause for concern for the additives industry is, in the past, you know, API, ILSAC, ASEA, all of these groups have been a balanced organization between, you know, members being from the OEMs. We also have hardware manufacturers like engine manufacturers. You've had obviously the lubricant additive companies. You also have even base oil companies. So essentially all the value chain players were helping set these specifications. You know, you want that kind of give and take where you see what's doable, where, you know, where you can push your limits. In this IFC organization, you're essentially only having the OEMs. So it's not that they won't hear and that the others can't participate, but it's no longer required a consensus for the new specifications to be formed. And so that's definitely a new trend. You know, certainly we'll cover more in the next iteration of this lubricant additive study as we learn more about this organization. But, you know, things like that are what's affecting additives. As I said, as far as regulations go, you know, things like IMO 2020 REACH, for instance, the cost of REACH has ruled out a lot of smaller volume additives where, you know, it's just not financially feasible for companies to register and import certain additives because the volumes just don't bring back the amount of money it costs to register them. So we're seeing a lot of consolidation, especially in the metalworking fluids segment, as far as the different types of additives used in those. So this is kind of everything we cover in the study. Now, some of the interesting spots. Now, you guys were certainly interested in EV fluids. Now, at Klein, we've launched a couple studies separate from mine that are covering only EV fluids, EV sales. So, you know, we have like PCMO 2040 and things like that. But from the additives aspect, we did try to cover some of the new EV fluids. We noted that many companies, many lubricant marketers are offering EV only lines. And part of it is trying to dig into the EV fluid aspect, which has been a bit difficult. Now, the reason it's difficult is right now, I mean, obviously your main marketer is Tesla. Then you have, you know, obviously GM has some EVs, and some of the other, you know, like Porsche as well. They all have a few EVs out. But a lot of these electric vehicles, they're still using traditional ICE lubricants. They're using traditional gear oils or ATFs, or obviously not engine oil, but they're using the typical coolants that were found in a vehicle. And so right now they're still kind of using legacy level fluids, and it's not that they don't function, but as these EVs kind of age, as they are in the market for a period of time, we're only now starting to see some of the problems that EVs face that are different than an ICE vehicle. For instance, we obviously know that there's no combustion engine, so you don't have an exhaust note in an EV. So essentially, they're very silent. So that silence has brought about a lot of other problems for lubricants. Things like grease for bearings or gear oils. you're hearing a lot more of the whine or the ticks or the sound. So where traditionally, you'd have a 4-cylinder or 6-cylinder engine with an exhaust note kind of covering any little ticks in the bearings or any whines from a gearbox, or, you wouldn't necessarily notice these sounds. But because these vehicles are EVs and they're fairly silent other than a motor hum, consumers are hearing these sounds and they're complaining about these sounds. So then, we're learning that EV fluids, for instance, that it's not so much that a bearing would be non-serviceable after, say, 100,000 miles or the life of that fluid. It's that, certain things will come up where maybe there'll be little pits or something in the bearing that would have been tolerable in an ICE vehicle. But in an EV, you're going to hear this constant tick, 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 tick as the bearing turns over. And so these are problems that EV fluids are facing. So as we kind of go forward, we're learning where the problems are. Obviously the EVs face, like for instance, there's a lot of eddy currents when it comes to the EV gearbox oils and things, because you have the electric motor very closely tied to that gearbox with high currents, high electromagnetic fields. And so you're going to get arc related wear, you're going to get other aspects. I mean, as I said, EV fluids, we're learning about it, and we tried to cover as much as we could on the EV fluids in the study, but it's very nascent as far as the problem set to, where it needs addressing. But essentially what we're finding out is, the EV, even the companies like Tesla, they're basically slowly finding these problems. And as they're dealing with recalls and, customer complaints, that they're starting to address the issues there. And as well, we're seeing things like how to properly and best cool the batteries. Is it fluid? So we know, companies are working on base oils and lubricants that can do direct cooling of the batteries versus, say, a water-based glycol type coolant that requires piping and aluminum heat sinks and things. Instead, you're having direct immersion in the cooling fluid for the batteries and components. So we're seeing a lot more, and basically as the technology settles in, as people find the best ways to kind of go about making these new EVs, you're going to see a lot more of these EV-based fluids kind of find their own special niche in the market and eventually start growing even more once EVs really start to take off. Some of the other issues we're seeing, as far as market trends go, you're seeing things like, again, with EVs, you're seeing competition for lithium grease. Obviously, lithium prices have gone up, and, like I said, we try to cover some of the market trends as far as what's going on. And so with the increasing cost of lithium for lithium grease, we're actually finding that like calcium complex greases are growing. Because traditionally the calcium complex grease has been a little more expensive than lithium-based grease, but they do offer better performance. Once you see kind of the lithium calcium complex pricing go on par, then people are switching to the calcium because it offers a somewhat better performance. And if it's the same price, then why wouldn't they? Obviously, for the whole greening future, we're seeing a lot more natural gas use. You're seeing it even in locomotive, where you're getting basically these hybrid engines that are part natural gas, part diesel. We're also seeing one of the interesting aspects I put in there is entry-level synthetics. Now, I don't quite know if that's a full category yet, but I classified it as entry-level synthetics. And I put two examples on the right, North America. So in North America, you have obviously Amazon Basics. They started into the finished lubricants. You also have like a Costco, which makes Kirkland full synthetic. But, we've traditionally have always had stuff where it's like a super tech brand from a Walmart or, AutoZone or other parts might have their own house brand is really what it was. But really until things like Costco and Amazon brought it into market, these house brands have traditionally always kind of played in the low tier price point only. And so they never quite had the brand recognition. They were just simply, if people wanted the cheapest product, on the shelf, they looked on the bottom shelf and they found this stuff. Well, now it's finding itself right at eye level, mid shelf, and it's basically being marketed. And, I peruse the forums all the time trying to see, how people behave and act. And essentially where, you know, a traditional Walmart-based super tech would have, you know, it's a super tech. You use it. If you say you use it, you don't tell anyone you use it. You just buy it and hide it in the corner and hope nobody sees it. But these days, people are actually saying, you know, stuff like Amazon Basics and Kirkland full synthetic for like $12 for a 5-quart is just as good as your Mobile Ones or Pennzoils or your Castrol Edges and stuff. And so you get this kind of back and forth arguing on the internet. And so the reason I bring it into this study is, you know, how does the finished fluid affect the additives market? Well, these fluids are essentially very basic fluids. I mean, I've looked at some of the chemical specifications and technical bits and did some reverse engineering on some of these fluids. And essentially, you're finding a bare minimum additive package. I mean, you're looking at, you know, basically a conventional fluid or a basic fluid additive package popped into a group 3 base oil, and they're full synthetics. And so they're not wrong, they are full synthetic, but I guess where the issue comes in is that consumers have always been trained to see the base oil as the driver of if it's a synthetic or a conventional. You know, it hasn't been that the synthetic lubricant also brings along a synthetic additive package, which traditionally has carried stuff like VW approval and BMW approval and things like that. And essentially the additive packages were probably double what was in a conventional fluid. So when you had the transition towards more synthetics, additives, especially in PCMO, would start to grow. Well, as we're seeing these kind of entry-level synthetics really take hold, you're seeing that growth in additive slide. You're essentially having consumers switch back to very basic, very cheap fluids popped into because of the oversupply of group 3 into a cheap group 3. And so, you know, this is kind of a trend that we're also seeing. Whether, you know, how it goes, how companies can go forward and counter that trend, I'm not sure. But, you know, that's been an interesting aspect. Other aspects, we're looking at like both biofuels and e-fuels. Obviously, biofuels, we've had some issues with, and the industry already knows, you know, stuff like ethanol in our gasoline or biodiesel in Europe. There's testing in the specifications that account for a certain percentage of it. So certainly the lubricants have to handle that aspect. The interesting aspect is what things like Porsche are working on with the e-fuels. So essentially with those, the idea is to replace your gasoline or diesel with some sort of a carbon neutral synthetic fuel generated either from, you know, like a Fischer-Tropsch method or other methods. But essentially you're trying to synthesize gasoline or diesel. You're not trying to find an alternative. You're trying to synthesize the actual fuel through a carbon neutral method so that you can therefore convert the existing fleet to essentially carbon neutral, but without having to force people to change their vehicles, upgrade the entire infrastructure. So that's been interesting, and in the sense that we want to see how that goes. So how much of a direct drop-in are these e-fuels? Are they exact drop-ins? Is there some difference, you know, because they're all maybe the same, you know, chemical structure? Does that change anything with the way the fuel burns? Does that increase contaminants, do any changes? So that's certainly something we'll be monitoring going forward. And then, as I said, the other thing is, you know, you see the greener carbon neutrality of everything. So you're seeing companies like Volvo and other companies where they commit to a certain level of carbon neutrality across not just their vehicles, but the supply chains, which means, you know, the additive suppliers for the finished lubricants, all that. They're going up and down their value chains trying to reduce their carbon footprint. So then that becomes a challenge as well for additive companies. How do they then produce product and provide a low carbon product? You know, so a carbon neutral product would be ideal. And so that's certainly a trend in the market where we're going to see a greater drive for that in the future. As I said, it's just kind of starting. A couple OEMs have started now, but it hasn't hit into full tilt just yet. But give it like roughly 5, maybe 10 years, and you'll start seeing a lot more initiative as far as greening the supply chain. And let's see. Now, COVID-19 obviously has been top of mind, well, was top of mind for a lot of folks for quite a while. We all know the short-term impact. You know, people stayed home, the businesses were shut down, travel restrictions. We also had a lot of supply chain bottlenecks where, you know, if additives or certain raw materials were sole sourced, like say castor oil from India and other aspects, then you're finding that you had a lot of issues. And right now we're certainly seeing a lot of lubricant marketers, like finished lubricant blenders, running into these issues now, because a lot of the bottlenecks, obviously, even if they've stopped, you've had that supply shortage and the issues we're seeing, even with semiconductors for like vehicles, but you're seeing on the lubricant additive side where a lot of lubricant marketers can't buy enough additive to produce the products for their customers. And so we're seeing that now. And I mentioned this earlier, where the lubricant additives industry was sort of saw a lag in the effects of COVID, where they didn't have the decline in demand initially, because, as I said, lubricant marketers were blending at full tilt to make sure their tanks were full, their packages and warehouses were full. And so now you're starting to see a lot of that impact, where people like shift forecasts. They expected COVID to last longer, and they plan buying less additives, less fluids, and so you're seeing that kind of where really additive demand has kicked back up to full tilt almost. You're not seeing the supply chain kind of match, and so you're seeing a lot still short-term bottlenecks. So as far as long-term effects, we're seeing, obviously there's going to be some industry consolidation. The reason being is any industries that were too leveraged or financially a bit, if start with, you're going to start to see greater closures of businesses, suppliers. You'll probably see this a lot more in the, not the additive package suppliers, but more down the value chain, where you start to see the raw suppliers, the neat additives or the components. You're also going to see some supply chain strategy shifts, where in the past, people may have built large plants in, say, China. There's second thoughts about having a single region or a single country supplying globally, whereas there's more consideration now for spreading out the supply chain so that it mitigates any of these risks a little bit better. And then overall, you're also seeing longer term impact, where there's going to be a lot more work from home for consumers. So PCMO is not going to pick up to exactly where it would have been or could have been had COVID not happened. And so you're seeing a lot of companies say, you know what, work from home works. And so you're seeing that. You're seeing like a deurbanization, where people that are allowed to work from home, they no longer need to live in London or New York City or other aspects, because, well, now you can choose to have a more affordable home in the countryside. And so how does that affect the mileage? So things like that. This is kind of what we're covering. It's also the kind of interesting aspects as far as what affects it. We also profile the lubricant additive companies. I realize I'm talking a bit long on some of these. And so, the additives industry is basically split into two categories. So you have component suppliers, which might supply either a precursor to an additive or the finished additive, in the sense of they supply antioxidants or detergents or other particular components. Then you have additive package suppliers. These guys work with OEMs. They approve products to specifications. They work with the lube marketers, and they essentially create the finished lubricant additive packages, which part is based on components that they manufacture. Part is also based on components that they purchase and use. Now, there's four major additive package suppliers. That's obviously Lubrizol, Infinium, Oronite, and Afton. Lubrizol is the largest company, and they certainly have quite a big breadth as far as the additives and the segments that they cover. Now, there's also, like, I say there's more than 20 or 30 other components. There's actually hundreds, but when we looked at the certain scale that to have a big enough scale, there were like 20 or 30 other component suppliers. These are top in their own industry. So you have companies like Evonik, Elco, King, Croda, E&I, like even Chinese additive suppliers like Tianhe or Wuxi South. But you have a lot of other additive companies also supplying. And a lot of these smaller additive companies are also kind of trying to chip into the big, where they're trying to make their own additive packages. Now, typically these guys start with smaller, easier to formulate additives. So they might hit a lot of general industrial fluids, or like a gear oil or a hydraulic additive package. And they tend to leave things like engine oils to the big four. But even then, you're starting to see them essentially try to chip in and start to erode some of the market leadership of those big four. Now, the one thing about the industry is between the big four, there is a lot, I mean, decades and decades of knowledge that these companies have acquired, and as well as like partnerships and ties with OEMs. It's very hard to replicate what they have. So certainly, smaller additive companies are chipping away at it. They're poaching off, retired folks or other people from the industry. And so they're trying to gain it as quickly as they can. And they are. They really certainly are gaining speed as far as gaining that knowledge. But I'm just saying there's a rather high barrier to entry to gain that full depth of knowledge that a lot of the majors have. So same thing with even companies like Evonik. I mean, there's very few companies that would know more about PMAs and PPDs than they do. And certainly it's not something easily replicated. Let's see. And with that, basically, thank you for joining me. Overall, like I said, the study is almost 700 slides. We dive into every single segment that we can, engine oils, ATS, PCMO, MCO, railroad, marine, all this kind of stuff. We try to cover similar aspects, which is what's impacting the market. Is it additive? Is it regulations? Is it specification upgrades? Is it a trend towards like, for instance, metalworking fluid? We're seeing a trend toward safer fluids, better for employees, so more HSSE or safety oriented fluids that have less like misting or other aspects. So we dive into what's affecting each type of fluid. And then as Raman said, for each subscriber to this study, we can provide a tailored, more detailed discussion. So, but yeah, thank you for having me, and I'll pass this back to Raman.
David, thank you very much. That was very interesting and very engaging. We do have a few questions. Well, we won't be able to answer all of them since we don't have that much time, but we'll make sure that the questions that we do not address now, we will address over the email. So the first question that we have is, how do you think e-fuels could be a serious option? Will they have a real chance to be an alternative to e-mobility, as e-cars are pushed mainly?
I mean, obviously that's going to be subjective to each opinion. Now, my personal opinion is how quickly and how much scale they can get, because in theory, if you can make an e-fuel like essentially a carbon neutral gasoline or diesel fuel that essentially could green our vehicle parks like next week, then I would think it would be kind of silly for a politician not to accept it. Now, on the other hand, our politicians aren't necessarily logical. So they're full 150% behind EVs. So that's kind of the future we're going to. And it's fine. EVs are great. They're cool. But it seems EVs, no matter what, are going to be the future. The only thing is, if they could make this e-fuel bit, it would be a good stopgap. So a way, as we try to upgrade the whole power infrastructure and everything, it'll be a way for us to bridge the carbon output gap. So certainly, I think they have a part in this role, but I just don't know how long for they'll do it. And really, it depends on what scale they can get it to. If they can't get it to a large enough scale, then I don't know how much of an effect they'll have.
Yeah, thanks very much. I'll read one more. What do you think about backwards compatibility for PCMO or HDEO? Will it always be required in the future?
Yes, it depends on which organization said it. I don't know how the IFC is going to behave going forward, but traditionally, yes, they've always at least maintained some category that will have a backwards compatibility. Now, you saw that deviate with the new API ILSAC specs. So where you have a GF6B or an FA4, those are actually not backwards compatible categories. And so But at the same time, they released the GF6A, which is backwards compatible. Same thing with CK4. So you're always going to have that requirement because, you have to take care of the existing fleet. Fleets don't just disappear, tomorrow. Even older vehicles, like say when China forces, non-emissions compliant vehicles off the road, they simply get sold to neighboring countries and used there. So vehicles have a very long life. And so you're going to need to service those vehicles. So you're always going to have that requirement. And I believe going forward, they'll still at least maintain a separate category for that backwards compatibility.
Thanks for that, David. We have time for one more question. What impact will electric vehicles have on the additives market?
Well, certainly you're going to see a lot of additives decline because engine oil consumes a lot of additive. So you're going to see less additive needed, but at the same time, EVs provide an opportunity. I mean, chances are EV fluids are fill for life, so you're not going to see the same type of service fill required. So it's all going to rotate around factory. But the other aspect is they will need a unique fluid, and it doesn't mean they'll continue to need some form of lubricant. No matter how people attack the fossil fuels industry, you're still going to need lubricants for these EVs. You're not going to get a motor to run dry. And so you're going to have a use, as I said, for these unique fluids. They're going to run into certain problems that going forward, these additive companies get to help solve. So, is it a certain additive that can help, reduce, let's say it's micro pitting in a bearing or whatever it is that is causing the sound to increase as these bearings age, or cause like current arcing within a transmission bearing and other aspects. And so the additives industry certainly will play a key role in that, but I think as far as EVs go, they'll have to factor in lower fluid volumes and certainly a much lower service fill industry.
David, thanks very much for the engaging presentation, and thanks for answering those questions. As I said in the beginning, today's free webinar, we focused on the global lubricant additives market. We covered top line findings from our study. Please do subscribe to our study. And as a part of the subscription, you will also get an in-depth presentation. Also, on June the 15th, as I also mentioned, we'll have a webinar in a series of In Conversation With. And this week you'll be receiving a webinar invitation for that session as well. So thank you very much, everyone, for joining us today. It was a very great, very interesting presentation. It was very engaging as well. So this is goodbye for now, and watch out for our upcoming webinars. Goodbye, and thank you.
Everyone be safe.